Hello, welcome to the video lecture series brought to you by Saitm Institute of Technology and Management. My name is Ravinder. I am an assistant professor with ETC department, and we are discussing the subject called Programming for Problem Solving Using C Language. And in the series of video lectures, we are discussing a very important topic called pointers. We have just started that particular topic, pointers, in the last lecture. Now, today, we are going to finish the concept conceptualizing this particular topic called pointer. So we are going to extend the topic of pointer in this lecture also, and after that, in next two lectures, we are going to actually see the real time application of these pointers. So today we are going to see just an example to see how pointer works in the terms of C syntax and how the things will unfold. After that, in next two lectures, we will see actual problems which can be solved using pointers quite easily as respect to the conventional method of solving the problems in C. Okay, so let's begin. So yesterday we have seen what are the pointers, how we are going to initialize the pointers, and what we have to do to start the pointers do their magic. So today we are going to see that particular implementation. So let's start writing the code. So I'm not going to write any functions or anything else like that. I'm going to just explain to you how the basic pointers will behave will behave according to your C compiler. That is it. Okay. We're not going to go in much detail right now. I've left a very significant or a quite difficult problem for next few lectures. So we'll see an actual real life problems that can be solved using the pointers in next few lectures. But in today's lecture, we're going to see how pointers actually behave inside the syntax. We have not seen that particular implementation in the last lecture, though we have discussed how pointers behave. I have give I have provided you with the concept of pointers, but we haven't seen that particular implementation. So that is what we are going to achieve here in this particular lecture. Okay, so I am inside the main. So let me first initialize and declare and initialize a particular variable of type integer. You can take any type of integer you want, any type of variable you want and any name you want. It is up to you. I'm just showing you for the sake of convenience, and easy names for the sake of convenience. Okay, so I will declare an variable which will be called with the name of I and is of type integer, and I will declare initialize its value equal to, let's say, 5, and I'll also initialize a pointer variable which we have discussed yesterday, how to initialize how to declare a pointer variable. For declaring a pointer variable, all you have to do is just precede the variable name with indirection operator or as at risk operator, or some of you may call it star operator in layman terms. So I will name it as J. So from this first line you can conclude that we have initialized a variable called I with value 5, and I have declared a pointer variable with name J. And how do I know that it is a pointer variable? Because the name J of the variable is preceded by an at risk or indirection operator or star operator. Okay. Now, as you know that the pointers always holds the address of a particular variable. Now, what kind of particular variable will be decided by the type of the pointer variable. Now, in this case, the type of the pointer variable is int, that means integer. It means J actually holds the value, J actually holds the address of an integer variable. Let me again say that J holds the value, the address of an integer variable, and this complete syntax called address j or pointer j actually conveys to us the value at the address which is being pointed by the j. Okay, so j contains the address of an integer value, and the indirection operator tells us, okay, fetch that particular value which is at the address, and that address is stored in G. That is what I am trying to say here. Now, first thing first, I haven't initialized the value of J yet because J doesn't contain any address yet. So let's try to connect I and J. So I will initialize the J with address of I actually, and you people must be familiar now with this particular operator called ampersand operator. It conveys the address of. Okay. Now with this line I'm trying to say here is, okay, uh, in this particular variable j I must store the address of variable I. Let me remind you that again, I'm not talking about the value of I, I'm talking about the address of I. Now the whole procedure is completed. Now J is actually connected to I. Now let us see how these things behave. So I will write a few printf or standard output functions. Printf, and let's first try to print the value of I, which is 5, but we'll still do that. Percentage d as it is an integer, and simply put I. And let's also try to print what would be the address of the variable I. As I is a variable, so compiler must have reserved a memory location for it. So let's try to find out what is the actual address of that particular memory location. Okay. So printf. Now I will not, the format specifier of an address will always be percentage %u, and u terms for unsigned. Okay, what I'm trying to say here is the format specifier for an address is percentage %u, and from u here I mean unsigned. Okay, now we discussed this earlier in the lectures. What is unsigned numbers? Unsigned numbers are just the whole numbers, okay, without any sign, and these are pretty perfect for describing any, let's say, memory location. Okay, so I will write first, I will try to print whatever I'm going to print in this line in the next line. So I'll use this n sorry backslash n, that is the access modifier, right? It means new line. Whatever I'm going to print by this particular command should be in a new line, and then percentage %u for an unsigned number. And then now how do I get to know, or how can I access the address of a particular variable? Now we have already done that in this particular application. We have used the ampersand I, and ampersand I always conveys the value, that is the address of a particular variable. So I'm using ampersand and I. We have used this particular operator in the scanf function, so we have discussed that already in the last lecture. Okay, now first two lines we have written here. The first line conveys what is stored inside the I, and second line will print the value in a new line. What is the address of that particular memory location where that particular where that value 5 is stored, which is being pointed by us as I, which we know by the name of I. Okay, now let's try to print what is inside J, only J. So I'll again have in printf, and now I know that from this line I know that J contains the address of a variable called I. Okay, so it can't be integer because addresses can't be a negative value, so I must use the format specifier as %u, as I have done in the line above it. So it's a new line and %u, and I will just write j, and in the next line let's try to print what does pointer, sorry, what does pointer signifies to. Now, any variable preceded by an address means the value at the address which is stored in that particular variable, or in this case the value that has been stored at the address pointed out by g, means now we are talking about a value, not about the address. Now we know that in this particular case the value is integer, the I contains a value that is of type integer, so the printf function must know that it is going to print an integer value. So new line, and I'm going to use the format specifier as %t for integer, and I will write pointer j in this. Okay, so let's try to implement that. Okay, so I'll minimize it and then we'll see what is happening. Okay, and now let's compare those results. The first line which says I must print the value of I, the value of I is actually 5, that is okay. The next line says that you must print in a new line that has been specified this by this \n, the address of I. Now address of I in my system is 6487572. It might be different in your system, that is according to the system capacity, that is the memory capacity. Okay, it might be different, but the thing is we are not concerned about the value, we are more concerned about what we are getting here. We're getting the address of the memory location in which the value 5 is stored, which we know by the name of I. Okay, now in next line, that is this particular line, third line, we have told printf to print what is being stored inside j, and we know inside j we have the address of the variable I. Now you can see the second and third line are exact copy of each other. So it has been confirmed that the address of I and what is inside j are equal or same, not equal but same. Now comes the interesting part. Let's say what has been, we have told the printf function to print what is the value inside the address of a memory location which is stored by J. So J stores an address of a memory location, and this address or star or indirection function is telling us, let me fetch that particular value which has been pointed out by the address which has been stored in J. Okay, now J stores the address of I, which we have confirmed in this particular line. So this particular thing is saying, okay, what is the value which has been stored in this particular address, this 6487572. Now in this particular memory location, we have integer value 5 stored, and that is what has been printed here. Okay, so pointer j or indirection j or address j is actually an value, not an address. So the ambiguity that what is j and what is the pointer j, I think it must have been removed or must have been gone by now. We have made it, I have tried to make it pretty clear that the star j or address j means the value at the address which has been stored by a particular variable, and only variable or only pointer variable will store the address of some particular memory location. Okay, so okay, now the last concept of pointers is that we are allowed to have pointer of pointers. Let me say that again, that we are allowed to have pointer of pointers. We haven't seen that yet. Let me first go to this. So we can initialize, like in the last example, we have initialized something like I and equal to value 5. And I have initialized a pointer variable with using j. And now let me initialize something more called star star k. And if I write like j must contain the address of I and k must contain the address of j. So what is actually happening here is, let me take help of some graphics. So okay, mm, so must have to, you can do this. Okay. This is, now let's say this box is the memory location reserved for j. I'll write j here and then equal to, and so now j stores a value. Let's say the memory location for I is, let's say, large, any random fairly large number, 642876. Let's say this. Okay. Okay, we have some disturbance here, so I will try to remove. I will remove this. So J now contains this particular memory location, which is actually the address of variable I. And now what I am saying is, what I have done here in this particular line is, um, let's first assume that the J has been reserved at a memory location called 783456. So this is the memory location for J, and J actually contains this value, and this value is actually the memory location for I. Okay, so I am now saying that K actually stores 783 and 456. Okay, so by this line I have done this. As you can see, the memory location in which I is stored is now inside the J, and the memory location reserved for J is now stored inside the K. So K is actually pointing to the address of J, and J is actually pointing to the address of I, and I actually stores a value. So by writing this particular variable here, or declaring this particular variable here, I am saying that what is the, again please keep vigilant, keep focused for this particular one line, that it is saying that what is the value at a memory location whose address is being pointed out by the address pointed out by K. Okay, so it is, again let me again say that, let me try to write it somehow. So this is saying as, so what is the value at the address pointed out by the J variable whose address is stored in k. Okay, so what is the, you have to break apart this. So what is the value? Let me have put some commas. Okay, what I have done, this is the first phrase. What is the value? At the address pointed out by j, not here, and whose address is stored in k. That means what is the value at a memory location whose address is inside j, and j's address is actually inside k. Okay, I think we are pretty clear now. Let's try to implement this particular thing. So I will declare another variable, and just we have looked, let's say, then let's name it right here, same k. And as we have done a few seconds ago, let's initialize the value of k with address of j. Okay, now, and first I will try to see what is the address of j. We haven't seen that yet. And if you are referring to an address, if you are trying to access an address or print an address value, we have to mention the format specifier as %u, obviously. So %u, and if I want to see the address of j, all I have to do is %j. And now let's try to see what is inside k, only k. So print f. Now what is inside k? Let me remind you that again, that k also stores an address of something. Okay, in this case, address of the memory location pointed or named as g. So again, in a new line, %u and k only. Okay, and in the end, let's try to see what does the pointer to the pointer of k indicates. So printf that, now here we are trying to access the value, not the address. So I will specify that with the access, with the format specifier which you have already initialized, or which we have mentioned for the initial variable. In this case, I is user of type int, so I will put it as d, and I will write k. Okay, let's save it, and we'll try to see what is happening actually. Okay, let's again see that in the manner we have seen before. I'll try to match it line by line. Okay, the first 4 lines we have discussed already. I stores a value 5, so it has been printed 5. The ampersand I stores the address of I, that has been mentioned as 6487572. J contains actually the address of I, so it must be same as above, 6487572. And the pointer j actually signifies the value at the address pointed out by the j, so it contains 5. Now what is the address of the j? That is the, what is the address of the memory location which has been reserved for j variable is 6487560. Okay, this is a new memory location. I'm not concerned about the memory location. Now we have tried to see what is inside k. Now I must remind you, as we have declared here in this particular line, the k stores the address of j memory location, or k stores the address of the memory location reserved for variable j. So it must be same as above. That means this particular line and this particular line here must output the same value, and that has been confirmed by the console output here, that for k actually has same value as the ampersand j has, that is the address of the memory location reserved for J, that is 648756. Now we'll try to see what does this pointer to the pointer K signifies. It signifies what is, in very layman terms, it signifies what is the value at a memory location. Okay, what is the value at a memory location whose address is stored by a variable, and that variable's memory location is stored inside U, and that U is K. So K stores a address of a memory location, and that particular memory location stores address of another memory location. And what is the value in the last memory location? And we know that K stores the address of J, and J actually stores the value of I, and I actually stores the value 5. So it has been printed 5. Okay, so this is how chain works. So I think you people are pretty comfortable until now at this point with the concept of the pointers. We haven't seen an actual application of the pointers. We have just seen how pointers will behave if we try to implement them in an application. Not, this is not a real application. It is not doing anything. It's just showing us what is actually happening behind the scenes when we are trying to implement the pointers, and that is my motive here in this particular lecture. The actual or quite let's say uh, fairly large application we'll try to see in the next lecture. I'll try to implement a nice bind boggling, let's say, application in the next lecture, which includes pointer, that is, which takes helps of pointers. Okay, so I'll end this lecture right here. Thank you.